Hello guys, today we are going to determine the dispersive power of the material of prism using spectrometer. So the material apparatus required are spectrometer, mercury lamp, prism and a reading lens. So the formula which we are using here is W is equal to mu 2 minus mu 1 divided by mu minus mu 1. Mu, which is a refractive index of the material of prism, which will be determined by our experiment. So this is the tabular column which we are going to use in this experiment. The first tabular column says how to determine the angle of prism. So then the second tabular column shows to determine the dispersive power of the prism. So we will see now how to perform the experiment. So this is the spectrometer which we are using for our experiment, and this is the source of light, which is mercury vapor lamp, and we will be using a prism for this experiment. First we have to observe the slit from the eyepiece. It should be very thin. So now we will see how to take the angle of the prism. So we have to keep the prism's rough surface facing towards the eyepiece. Then we have to move the telescope towards left such a way that we will observe the same slit from here. Then we have to note the readings of vernier 1 and vernier 2. In the same way we have to rotate the telescope towards right and we will get the same slit here. So afterwards we have to note the readings for vernier 1 and vernier 2. So from the table we will be getting the readings for vernier 1, vernier 2 and vernier 1, vernier 2. So we have to subtract the readings of vernier 1 from the right side to the vernier 1 of the left side, and vernier 2 of the right side to the vernier 2 of left side. Then we will get two angle which will be twice of the angle of prism. Then we have to divide it by 2. Then we will get the angle of prism, which is A. So now we form the angle of prism. Now we have to take the readings for direct readings, which is vernier 1 and vernier 2. So for taking the direct reading without keeping the prism, we have to focus the telescope to the slit. Then we have to note the readings for vernier 1 and vernier 2. From this we will get the direct reading. So next to determine the dispersive power of the prism, we have to first focus the prisms in such a way that we will get the spectrum. So for this we have to keep it here. The rough face should be facing other side. The two refractive faces should be facing the light and the telescope. Now we will focus in such a way that we will get the spectrum. Now we will see the spectrum which we have got after focusing. So now we will see how to take the readings for minimum deviation. Once we will get the spectrum, we have to focus it on one color. After focusing on it, we have to move the table of the prism towards the direct reading, which is towards this. At one point of time, the spectrum will move back and will retrace its path. Once it will start to retrace, we have to stop to rotate the table, and we have to focus the telescope. We have to focus the color with telescope, and then we have to take the readings. In the same way, we have to focus for all the colors, and we have to take the readings. Not all the colors which have maximum intensity, at least 4 to 5 colors. Now we will see the experiments which we have done. So this is the diagrams which we have done. This is for angle of prism, and this is for taking the reading for minimum deviation. So now this is the table. This is for angle of prism. So here we have got vernier 1 reading for position 1 and vernier 2 readings for position 2, and this is for vernier 1 and vernier 2 reading for position 2. After subtracting reading of vernier 1 of position 1 and vernier 1 position 2, we will get 2A, which will be around 120 or 190. Then we have to divide it by 2 and we will get the angle of prism, which is around which should be 60, but we will get around 60. It may be 61 or 59 point something. So So this is a table in which we have find the minimum deviation. So these are for different colors. We have taken the readings. We have taken for violet, blue, green, yellow, red, and this is direct reading which I have taken before. So, in this, first we have to subtract color reading with direct reading with 1 year 1 scale, and colors reading with direct reading 1 year 2 scale. Then we will get the angle of minimum deviation. Then we have to take the mean of this. Then we have to find the refractive index. For refractive index, the formula which we are using is sin A plus delta divided by 2 divided by sin A divided by 2. So this is the formula which we will use to find the refractive index. So here we found the refractive index of the prism. So next here, this is the calculation which we have done for that. So formula for dispersive power is W is equal to mu2 minus mu1 divided by mu minus 1. So the maximum refractive index is taken as mu2 and the minimum is taken as mu1. So if we see here, red color is minimum and we have taken it as mu1, and the violet is maximum and we have taken it as mu2. The average of mu1 and mu2 is taken as mu. So after calculating, we will get the dispersive power of the prism. So this was the experiment which we have done today.